This is Unit 6, Lesson 6, Part 2. So we're working with the exact same set of notes that we worked with in the last lesson, except this time we're going to do all the cube root functions. So we've talked about the transformations already. We're just going to be expanding into a different type of function and how those patterns will look. So the parent function for the cube roots, remember functions always start with an f of x, and this is just a plain old cube root instead of a plain old square root. So the bend is going to look a little bit different. So when we set up our x values here, we can take the cube root of 0. So remember, just like we did up here, we're only going to use x values that we can actually plug in here. So then cube root, next one we can do is 1. Next one after that isn't till 8, and then after that it's not till 27, so that's way off of our grid. Now negatives are actually allowed with cube roots, because you can take the cube root of a -8, for instance, or a -1. So we can use a -1, we can use a -8. That'll be enough to see our shape here. So cube root of 0 is 0, cube root of 1 is 1, cube root of 8 is 2, remember, like 2 times 2 times 2, cube root of -1 is a -1, because if you multiply -1 times -1 times -1, it actually comes back negative. So same logic here, this cube root would be a -2. So this one doesn't just stop dead at the origin, it's going to keep going on both sides because you're allowed to use negative values here. So let's plot these. So 0, 0 right at the origin. 1, 1 would be right here. 8, 2 would be almost to the edge, and then up to 2. So our right-hand side looks a lot like a square root, but then it kind of mirrors over on the left-hand side. So -1, -1, and then -8, -2. So sort of does this symmetrical looking shape out in the other direction. So like it wiggles up, wiggles down. So a turning point is where it kind of like switches this little wiggly shape here. So here the turning point is at 0, 0. So just like the last lesson, any transformations that we have are going to shift where this turning point is, just like with square roots, it shifted where the end point was. Domain here, I can plug anything I want into a cube root function. So the domain is all reals. The range is actually also all reals, because even though it happens very, very slowly, it will eventually just keep going up and keep going down. So all y values will eventually get hit there, not just the positive ones like this. So that's our original function. Let's talk about some transformations. So these I feel like I don't need to recap because we just had a lesson on these. Let's see how they affect cube root functions rather than square root functions. So number 2 is a cube root function. You see this 4 out front right here. 4 falls into this category right here. It's a number out front. It's bigger than 1. That would be a vertical stretch. So we are going to say that there is a vertical stretch by 4. So remember when we did stretches with the square root functions, what this is going to do is every time that my original graph used to just go up 1, it's now going to go up 4. So this would be all the way up at 4, this would be all the way up at 8, and instead of going down 1, it would go down 4, and this would go down all the way. So it gets very stretched out. There's nothing underneath with the x, so there's no left or right movement. This -1 is after the radical signs, that would be down. So this is going to go down 1 unit, and that would move where my turning point is. Another one here. This first thing we see is a negative. The negative is this right here. It's going to be a reflection over the x-axis. So what that will look like is instead of this piece going down, this piece will go up. Instead of this piece going up, this piece will go down. So it's just like a flip of what the original one would look like. And then this, we have an x plus 3 underneath the radical sign right here. So that's an h, and when you see a plus, it's actually shifting to the left. So this is going to go 3 units to the left. So let's say left 3. All right, so that's what the transformations look like. We have one more on the next page where we're going to create our own graph. So a cube root function, so we know it's going to be f of x equals, has a turning point located at -2, +3. All right, so if we're looking at any of these, like this one, the point that we're mentioning is at -7, -1. So the turning point is at -2, -3. They don't mention anything about reflections. They don't mention anything about stretches or compressions. So we're just going to assume that we don't have any. We'll start off our square root. The x-coordinate is at -2, which means it's 2 units to the left of the origin. So 2 units left would have an x plus 2 right here. And then the 3 would be 3 units up. So that means after the radical, we have a plus 3. So that's what my equation would look like. And it says an equation because like they didn't mention a stretch or compression, but it might be there. So like you might have a different value of A out front, but this is just the most likely one. All right, so these are all square roots on the rest of this page. So we're gonna flip and do the cube roots that we've got, starting with number 11. All right, so we have 11, 12, and 13. So we're gonna totally finish off these notes. So our cube root, we're gonna talk about the normal pattern that we usually have. So like this is the usual pattern for a square root. Let's talk about the usual pattern for a cube root. So this guy right here starts at the turning point. That's always the first point we're gonna plot. From that point, it goes up 1 to the right 1, and then it goes up 1 to the right 7, because the x values jump from 1 to 8, so it goes over 7. So it goes up 1 to the right 1, up 1 to the right 7. And then it mirrors that back the other way. It goes down 1 to the left 1, down 1 to the left 7. So I'm gonna write that down. Our normal pattern goes up 1 to the right 1, up 1 to the right 7, and then we go back to the turning point, and it goes down 1 to the left 1, down 1 to the left 7. So remember those patterns. Learn how they get adjusted as you have our different transformations. So this is a cube root. You can see that. That's going to be the general shape of things. So it looks like this in general, but then any transformations will change the endpoint or possibly change how this pattern moves. So +3 means we go to the left 3. So the turning point would have an x coordinate of -3, and then +2 means up 2. So this is where our graph will begin. So let's plot a point there. So 1, 2, 3, up 2. So that is our turning point. And then from there, it follows this pattern unless there's a reflection or a stretch or a compression. A is just 1. There's nothing in front of this radical, which means it's just going to follow this pattern. So from the turning point, we can go up 1 to the right 1. And then we can go up 1 to the right 7. So here's 2, 4, 6, 7. Now back to the turning point. And then do this. Down 1 to the left 1. Down 1 to the left 7. So 2, 4, 6. We got to go 1 point off the grid here. So this is where the little wiggle happens. So it goes like this up to the turning point, and then it turns and kind of faces downward like that. So that is what our cube root function looks like. So notice, here's the original. Here's our new one. They look the exact same. It's not any stretchier. It's not upside down. The only difference is this one starts at the origin. This one starts left 3 and up 2, just like our transformation said we were supposed to. So now let's fill in all this information. Fun fact, every cube root function, the domain and range are both all reals. So we don't even really need to think about that. It's just always all reals. The end behavior is actually a little bit easier than the square root functions were as well, because on each end we have an arrow. It's just up to you to figure out where those arrows are going. So we usually like to start with the right arrow. Right arrow means x is approaching infinity, moving off to the right end of that graph. Now this right arrow is headed up. So for up, we say that f of x is approaching positive infinity. That's the first end. Other end is the left end right here, which also has an arrow. So for a left arrow, we say x is approaching negative infinity. And the left arrow of that graph is heading downward. So down means that f of x is approaching negative infinity. Remember, this means right arrow going up. This means left arrow going down. Comparing that to the square root functions, this one means right arrow going down. This one means it just stops at an ordered pair. When you put actual numbers there, it means it ends at an ordered pair. These don't end at an ordered pair. They keep on going to the left, they keep on going to the right, which is why we should see this each time. Now these graphs are also either entirely increasing or entirely decreasing. It doesn't matter that it has that little like wiggle thing going on. So this one increases the whole time. It starts at the left arrow and it ends at the right arrow. So for the left arrow, we start with negative infinity. For the right arrow, we end with positive infinity, and we always have parentheses on the infinities. So these are intervals of x values. So this just means all the x values, it's increasing, and it's never decreasing. So it's either one or the other, just like the square roots. All right, let's look at another one. Number 12 here. We have nothing in here, so no left or right movement. Nothing after, so no up or down movement. That actually just means the turning point is still at the origin. Now here's what this -2 does. It flips upside down, and it provides us a vertical stretch of 2. So I'm going to write what our old pattern is. Just copy this down right here. So initially, this is what our cube root graph does once you start at the origin or the turning point. Now here's what the negative does. What once went up will now go down, and what once went down will now go up. That's what the negative will do, is it flips the up and down. What the 2 does is it switches how far up and how far down these graphs are going. So what used to be up 1 is now going to be down 2. The negative changes it to down, the 2 changes it to 2. So we are now going down 2. We're still going to the right one, because like that doesn't change. That's not affected by this. And then up 2 becomes down, up 1 becomes down 2, and it's still to the right 7. This is never impacted by a stretch or a compression or a reflection. It's just the up and down, because that's just the vertical stuff. All right, so then we go back to the turning point. Down 1, down becomes up because of the negative. 1 becomes 2 because of the stretch. So this is now up 2, still left 1, that is not impacted. And down 1 is up 2 and left 7. So starting at our turning point right here at the origin, let's follow this pattern. So down 2 and to the right 1, down 2 and to the right 7. So you can see a little bit of a stretch happening there, and that's the reflection. Instead of going up to the right, it goes down to the right. And then back to the starting point, up 2 to the left 1, and up 2 to the left 7. So we follow this little pattern, looks like this. There's our turning point, this is where it has that little wiggle, and it looks like that. So you can see it's upside down compared to the original, and it's stretched out. This one like almost lays flat. This one starts to stretch out a little bit more because of that too. All right, cube roots, domain and range are always all reals. Easy to remember. End behavior. Start with the right arrow. Right arrow would be infinity here. This right arrow is going down. So this means f of x approaches negative infinity. So the right arrow goes down. Then we talk about the left end of the graph, which is a left arrow. And that left arrow is going up. So we use positive infinity for f of x. All right, and then increasing, decreasing, it's either all one or all the other. This one decreases the whole time. So never increasing. And then decreasing, we do the same thing we do here. From the left arrow to the right arrow. That's it, always decreasing. Okay, one more of these. This one, we start with our turning point. So turning point would be -1 for x, -5 for y. So we can start by plotting a point there. And then this 1/2 is going to be a compression. So old pattern. New pattern means every time we used to go up or down 1, we're now only going to go half a unit. That's what the compression will be. So we're going to go up just half a unit and then to the right 1, up another half a unit to the right 7. Remember, this doesn't ever change. The right or left doesn't ever change. Then back to the turning point, down just half a unit to the left 1, and then down just half a unit and to the, whoops, sorry, not right. This should have been left, and to the left 7. So from here, we're going to go up just half a unit and then to the right 1, and then just up another half a unit and then to the right 7. So this is going to be compressed. Then back to the turning point, down just half a unit and to the left 1, and then down just half a unit and to the left 7. So this one almost looks like it's flat because it's so compressed. There's not really a whole lot happening here. So it almost looks like a horizontal line. Little details to fill in over here. Domain and range is always all reals for every cubic ever. And behavior, we talk about these arrows. The right arrow we mentioned first. This right arrow is going up because it was not flipped upside down. The left arrow is going down. All right, and then increasing, decreasing. This one is always increasing. So just like number 11 up here, always increasing, never decreasing. So it increases from the left arrow to the right arrow, and it never decreases. All right, so those are your cube roots.